Remember a few videos back, I was always wondering what caused this shape of Hudson Bay and James Bay in this area of Canada, north of the lakes. And we already know that there is a gigantic mantle plume, horse-shaped mantle plume under the Great Lakes from about 1 billion years ago. The geologists don't know where it's coming from, but it's there. Horseshoe-shaped, the eastern part goes under the area of the New Madrid seismic zone, and the western area goes into the area of the plains and the rifting there between the Lake Superior and Yellowstone. There's Yellowstone right there. But I was always wondering what caused this thing. Look at how circular that is. And of course this thing as well. And we also have, of course, all these impact craters there. I always believed it could have been an impact. Look at this thing here. This thing here. This thing here, the Manicouagan crater in Montreal, in Quebec. Look at these things here. Those look like a double impact there. And I found in passing a very interesting article by a professor in geology concerning super-eruptions, concerning the Arctic. We looked at a couple of videos back at the warming of the Arctic. It's warming faster than the rest of the globe in the Arctic and melting. We found that we have volcanoes under Greenland as well that were recently found. We know Iceland is a volcanic island on the mid-Atlantic trench, but there seems to have been, and I don't know, I would venture to say that perhaps that also has to do with a hotspot area having to do with that mantle plume under the Great Lakes. It's not that much of a distance. What is it? It's less than 1,000. It's 500 kilometers. So he says, and he shows them to us. We know we have a lot of kimberlite volcanoes here. They're the diamond spewing volcanoes, like we have in Kansas and Arkansas, Oklahoma, Kansas mostly. But he claims that there are a succession of, we're going to take a look at the map, a succession of supervolcanic eruptions from supervolcanoes making a line into this area. Okay? Look at the crack. The crack seems to be going all around the world. Right there, that mid-Atlantic trench over the North Pole. Okay? Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box. In this article written by James Camus, and I'll leave a link below for you, he claims that there's a chain of supervolcanic craters in this area heading towards the Arctic, caused by super-eruptions. I mean, the size of these craters, I have never seen craters this big on any other place on the Earth. A 2,000-mile-long linear chain of giant craters located in the Arctic, he says, is likely the result of multiple supervolcanic eruptions associated with the movement of the North American plate continent across the underlying non-moving deep earth lower mantle superplume, the hotspots, what we call, and not random meteor impact strikes. Okay, other people call them comet or meteor strikes. He says it's a mantle plume and that they're massive imploding calderas. For many years, the debate has been waging between those who believe these Arctic craters are astronomical or in origin. In other words, we've had a celestial impact, and those are others favoring volcanic eruption origin. So those are the two sides of the coin. The recent discovery by NASA's of 2 giant craters beneath Greenland ice sheet is positioned along the Arctic crater trend has pushed the debate back into the spotlight of the volcanic activity there. NASA has stated that in no uncertain terms that these two new craters are of astronomical origin. In other words, they're huge. NASA said those advocating an astronomical origin of this chain of gigantic Arctic craters have failed to include two extremely relevant telling lines of evidence: the regional geological setting and the dynamic of supervolcanic eruptions. Now, the regional geological setting, critical factor in determining the origin of a giant crater, is to research and understand and then incorporate the regional geological setting. And if you don't do this, especially early on, leads to the investigation process that's too narrowly focused. So you have to prove this. Now, limiting the investigation area to a very small geographical area when reviewing world-class size crater features, especially those that occur in groups, is an inherently bad idea. The result of this narrow focusing is to bias the search for which massive forces or forces generated by generating these giant craters. Specifically, biased scientists to look upwards into the vast expanse of outer space rather than looking laterally at regional extensive geological features. He says, first we have to review and then determine the relevance of geological settings associated with a 2,000-mile line, a linear chain of gigantic Arctic craters. Several observations are extremely telling. We have a linear line, a giant linear Arctic craters positioned along the linear trend, which is unusual because meteor impacts are distributed randomly across the Earth and not aligned towards along trends. Individual craters along chains are progressively younger to the northeast, which is very unlikely, and some would say an impossibility. An occurrence of meteor strikes at a perfect alignment along a straight line is not possible, obviously. This is also extremely unlikely that a chain of individuals are millions of years of age. The trend coincides with the surface trace of a well-mapped major deep inner earth reaching fault. When a specific part of this major fault trend is activated, it acts to open up vertical pathways which taps downward into a huge fixed non-moving deep inner earth hot lava pocket, the magma chamber, from what we call a mantle plume, the hotspot. The tapping process acts to remove constating pressure on the magma chamber. The unconstrained molten lava then moves up. The unconstrained molten lava moves upwards along the ocean open pathway at a very high speed. Once this column of molten lava reaches the base of the Earth's outer rock layers, it spreads outwards, forming a mushroom shape of hot lava located just below the Earth's rocky layers. The portion of mushroom-shaped lava positioned below the major fault explodes upward and onto Earth's surface as a supervolcanic eruption. The magma chamber and tapping vertical columns represent one geological feature termed a lower mantle superplume. The associated violent surface eruptions are termed, of course, supervolcanic eruptions. This process seems overly complicated, difficult to understand, but it's a normal, very well-known geological process. It's important to clarify and describe the process in a detailed fashion to prove to readers in the Arctic chain of craters is definitely not a string of meteor strikes, rather a geological formed chain of supervolcanic eruptions. The Arctic chain of supervolcanic eruptions are of varying ages and have likely acted to dramatically alter Earth's climate at the time of each eruption. The long linear major fault involved development of the Arctic chain of volcanic eruptions was formed by the long linear sideway movement of Greenland across the fixed non-moving magma chamber movement of huge portions of Earth's outer rock, like Greenland, is termed continental drift. And as Greenland moved northeast over the underlying and non-moving huge lava pocket, it generated older and older supervolcanic eruptions. And explanation strengthened by comparison to another regional chain of long linear craters we know very well, the Snake River Plain, which ended up to about 17 million years ago and ending up to today's Yellowstone supervolcano. Now, concerning the dynamics of supervolcano eruptions, we know that we have over 21 supervolcanoes on the Earth today. The dynamics of a supervolcano eruption is not well understood, but recent research sheds light on how these monster volcano and supereruptions operate. Eruptions are located above major fault systems that tap down into the Earth's mantle, or more likely lower mantle, and these types of faults have complex plumbing systems, large open ventricle pathways that allocate expulsed lava to rise upward at very high speeds. Eruptions occur periodically as high pressure in the deep lava pockets exceeds the capability of vertical fault system to keep the lava chamber from exploding. High pressure pulses are the result of rapid warming of water present in the hot lava and not a movement of the lava pocket. Explosive release of huge lava pockets can occur in an extremely short time frame, as little as only 2 days, 48 hours. The dynamic of supervolcanic eruptions also affect the development of minerals within the hot lava mixture. So, for many years, the presence of the rare metal iridium in rock layers surrounding Earth's giant craters features was considered by many scientists to be as strong proof, as some said, absolute proof that the crater was of meteor impact origin. This was based on the then thought to be 100% settled scientific fact that iridium is common in meteors but extremely rare in Earth's outer crust rock layers. Therefore, finding significant concentrations of iridium in rock layers that form the circular rim of Earth's giant craters must be considered as strong proof of meteor impact origin. This supposed scientific fact has since been proven to be not correct, primarily because significant concentrations of iridium have been discovered in one of the largest outflows of molten lava on Earth, the Deccan Traps in Siberia. The geographically extensive geological feature is not a crater. It's now thought to be one of the primary, and some say the root cause, of the great dinosaur extinction. The Deccan Traps lava flows were sourced by an underlying major fault break extending towards the Earth's iridium-rich mantle. So that's from the iridium of the Earth mantle. It's now accepted that the presence of iridium in crater rocks is not absolute proof of a meteor impact origin, rather proof of a meteor impact or supervolcano volcano eruption. So, as was true with iridium, for many years, the presence of the rare minerals termed shock quartz in rock layers surrounding Earth's giant craters features was considered by many scientists as strong proof, and some said absolute proof, that the crater was a meteor impact origin. New research shows that shock quartz can theoretically be generated by supervolcanic eruptions, as has recently been proven to be the case with the transformation of carbon to diamonds. These findings contradict recent molecular dynamics simulation results for the shock-induced graphite to diamond transformation, providing a benchmark for future theoretical simulations. Now, other evidence, the Nastapoka arc, which is one of the larger crater-like features in the Arctic, and has been research proven to be absent of iridium and shock quartz, so it couldn't have been an impact site. This throws into question the consensus scientific theory that this crater and other craters along this trend are 100% proven to be astronomical origin. So they're not. They have to be geological origin. Regional geological mapping also shows that this arc is likely not of meteor impact because of the arc. It's not circular, rather a distinct semicircular, sharply cut off by a major fault line. Recent research studies confirm that all of 5 Earth's climate-altering mass extinctions are the result of massive, world-class pulses of volcanism from land and ocean geological features, including the previously thought meteor impact end of the dinosaurs. In summary, abundant, reliable evidence indicates that a long linear chain of giant crater features, caldera features, located in northeast Canada and northern Greenland are of super-volcanic origin and not astronomical, including the 2 recently discovered giant subglacial craters, calderas, features in northern Greenland. In the past, the scientific community has in some cases narrowly focused their investigation of Earth's giant crater features in limited geographic regions, thereby not properly evaluating the significant and regional geological setting. Also, they have not correctly interpreted the presence or absence of iridium and shock quartz, nor have they taken into consideration the growing amount of evidence that supervolcanic eruptions are a different kind of beast. So you see how important it is to take very good account of not only space but geology as well. All the evidence. This is on Planet Climatology by James Camus. Please leave your comments and thank you for your support. So we found out what caused this strange shape in the Hudson Bay, James Bay of Canada. The fact that also we have this huge line of supervolcanic eruptions from Canada heading into Greenland. And these must have been something beastly, obviously. Tremendous amount of activity. Please leave your comments and thank you for your support.